Hi friends, today I am discussing about the oxidation number. In this class we can determine the oxidation number of the element for some complicated complex or complicated compound. Already we have discussed the oxidation number, how can you calculate the oxidation number. Here Mg2C3, this name is magnesium carbide. Here we can determine the oxidation number of carbon. So star is assigned, oxidation number is carbon. So the oxidation number of magnesium is plus 2. So number of magnesium atom is 2. And let us consider the oxidation number of carbon is X. So 2 into plus 2 for magnesium plus X into 3. Summation of the oxidation number equal to 0. So what is the value of X? You can calculate. Okay. Next, the K2FeO4. We can calculate the oxidation number of Fe. The oxygen is minus 8. Oxygen is minus 2. The number of oxygen atom is 4. So 4 into minus 2 equal to minus 8. Potassium is plus 2. So summation is 0. So Fe is plus 6. This name is compound is very important, DMSO, that is dimethyl sulfoxide. This compound is similar structure of acetone, CaCO, acetone, and this is dimethyl sulfoxide. Here the methyl group, the total part, the oxidation number is minus 1 and this is also minus 1. Because it can exist as methyl CH3 minus CH3 minus in this compound. Because it 2CH3 minus plus SO2 plus, it can exist as. And so oxygen here, this is a minus 2. Normal oxygen minus 2. And so the oxidation state of sulfur, total summation of the oxidation number is 0. So oxidation number of sulfur plus 4. Next, FeS2. We can calculate the oxidation of sulfur. We can calculate sulfur. Fe is plus 2 state. Fe is plus 2 state. So let us consider the oxidation state of sulfur is X. Now 1 into 2, because oxidation of Fe is plus 2, because Fe exists as Fe2 plus 2 plus 2 into X. 2 into X sulfur, let us consider oxidation of sulfur X, 2 into X equal to 0. Then you calculate the oxidation number of sulfur, O2F2. Here the oxidation number of oxygen is plus 1. This is an exceptional compound. In majority of the compound of oxygen, the oxidation number of oxygen is minus 2. But in case of O2F2, the oxidation number of oxygen is plus 1. N3H, this compound is known as hydrazoic acid. The compound is known as hydrazoic acid. Here the calculate the oxidation number of nitrogen. Then let us consider the oxidation state of nitrogen is X. So X into 3 plus 1, hydrogen plus 1, the common state equal to 0. Then you can calculate what is the value of X. Next compound, PTNH3 the whole to Cl2. PTNH3 the whole to Cl2. This complex is known as cisplatin. This complex is known as cisplatin. What is the oxidation number of platinum? Here Cl is a negative ligand, so the contribution is 2. Ammonia is the neutral ligand, so the contribution is 0. So overall 0. So overall oxidation number is 0. So platinum, what is the state of platinum? The state is the plus 2. The PtC2H4Cl3K, this salt is known as Gise's salt. To be important. This is the plus 1 potassium, Cl negative ligand, this is the minus 3. C2H4 neutral ligand, this is 0. Overall oxidation number কত হয় summation 0. So this is the plus 2. FeH the whole 5 NOSO4, this compound is known as brown ring compound. This compound is known as brown ring compound, and so this sulfate is minus 2. NO is exist as NO plus. Always NO is exist as NO plus. H2O5 is neutral ligand, so contribution is 0. Overall oxidation number summation equal to 0. So maybe 0. So the state is the plus 1. This is the Na2SO4O6 sodium tetrathionate. Here the oxidation number of oxygen -2. This is -2. This oxygen is -2. Sodium is +1, and this oxygen -2, oxygen -2, sodium +1. So -2, -2, -2, -4, -6, -8, -10, -12, -12, 12 +1 and +1, +2, -12 +2. Ultimately, so again we made it. So sodium 2. So 2 into 1 oxygen at 1, 2, 3, 4, 5, 6. 6 into -2. Sulfur star plus 2x. This sulfur is considered 0 because there is no electronegativity difference. So this is a 2 into 0 equal to 0. Then you can calculate the x is equal to 5. You can calculate. Next, the H2O2 hydrogen peroxide. What is the oxidation number of oxygen? This is the -1 because the bond is Pareto bond. Okay. So in this class we can calculate the oxidation number of the very complicated compound. Thank you. About the topic of oxidation number method. By this method we can balance the redox reaction. The redox reaction here is given by CuO plus ammonia to form Cu plus N2 plus H2O. Here the oxidation state of copper is +2 and here the oxidation state of nitrogen is -3. In product side we have seen that the oxidation state of copper is 0 and the oxidation state of nitrogen is 0 because these two form can exist as elementary form. So the oxidation state is 0. Now the oxidation state changes -3 to 0 in case of ammonia. So in this case oxidation is occurred. So change of oxidation number 0 -3. So ultimately 3. Here the oxidation number changes from +2 to 0. That is reduction is occurred and the change of oxidation number is +2 minus 0. That is 2. So the ratio of copper is to nitrogen equal to 3:2. That is reciprocal of nitrogen and copper. That is 3:2. This 3:2 value putting in this equation. That is here the 3 and here the 2. That is here the 3 and 2 and same product side. The 3, 2. So the overall reaction is given by 3CO plus 2 ammonia, 3Cu plus N2 plus 3H2. Here the nitrogen atoms number of atoms is 2 and here the 2. So the number of atoms is same in reactant and product side, and this is the result of the final equation which can be solved by oxidation number method. Now the another example, here copper plus nitric acid, copper nitrate, nitrogen dioxide and H2 is formed. Here copper nitrate can exist in salt form. So copper is 0 and in copper nitrate it can exist as +2 form. Here in nitric acid nitrogen exists as +5, here nitrogen exists as +4. Here copper 0 to +2 changes, oxidation number 0 to +2 is occurred. That is oxidation is occurred. Here in nitric acid the nitrogen is +5 state and nitrogen dioxide in nitrogen is +4 state. So in this case +5 to 4 is occurred, that is reduction is occurred. So in case of oxidation the change of oxidation number is 2 because 2 minus 0 that is 2. But in case of reduction the change of oxidation number is 5 minus 4 that is 1. So copper, the change of oxidation number in case of copper is 2, the change of oxidation number in case of nitrogen is 1. So the ratio is copper is to N equal to 1:2. That is the reciprocal of copper and nitrogen. So this 1:2 putting this equation. So that is the copper 1 and 2N, that means 2HNO3 to form. Similarly, product side we have putting this value. So CuNO3 the whole 2 is a 1 and 2. So 1 is to 2, same 1 is to 2. CuNO3 the whole 2 plus 2NO2 plus H2O. Now we have seen that the number of atoms in both sides are not same, because here the nitrogen is 2 and 2, that is 4, but in this case, but left hand side the number of nitrogen atom is 2. So in order to maintain the balance in both sides, 2 nitrogen is added, that is the 4 nitric acid is required to balance the equation in both sides. Here the copper is 1, hydrogen is 4, hydrogen is 4, nitrogen is 4, nitrogen is also 4, and oxygen is 12, and here oxygen is also 12. Thank you.